All right, we're back. I got a new iron. So I think today I'll just work on, while I'm waiting for new parts come in, is take out the old caps. I already worked one in. Don't think I recorded or I lost the footage of that, so probably just today, just do a quick short video and then I'll compile all this up. And I got some needle nose to actually help me do this. So without hurting myself, hopefully. Trying not. And you know what? I have a temperature control, so let me just raise it up a little bit here. So I don't think I said this in the other, or the video I lost rather, but the eyelets are usually, or rather the connections that are made are typically the positive leads are just embedded within, and then they actually run the negative lead out to the big grounding strip. And so it's not always easy to take the negative lead out if they ran it. And this wire's in the way. Let me just push that over. So I'm going to try pulling the negative lead up. Yep, it's usually tight underneath, so for the negative ends, it's usually required that you just do some trimming of the lead. And for people who want to, for whatever reason, restore this to original components, I usually just try to leave as much as possible. There we go. And so theoretically, if you really wanted to reconnect this, although I wouldn't recommend it, that gives you enough to at least maybe join a connection to the original lead. But for me, I plan on using this thing, so. And I had noticed some of the resistors were out of spec. And I think I said in another video that the capacitors were out of spec, but I sort of foolishly forgot my electronic rules, which is for capacitors in parallel, the capacitance adds. And for the tone stack, these capacitors are in parallel. So I'm not sure I got a reliable reading for the 0.047 and the 0.1. But the values added together are about 147, 150 nanofarads, so, or 0.147 microfarad. So potentially these caps are okay. I think I'm gonna stick with my gut. I'm gonna leave them in and just not pull them just yet if I don't have to. And then these resistors for the cathode circuit on each of the tubes, these I think I need to check as well. I checked in for V1, or for input 1 rather, not the vibrato channel, but just a normal channel. Those resistors were okay. I'm gonna check these. I didn't get a chance to look at these. And then I did check over here, this value was off for the other cathode bias circuit on, I think it's the AT7. I have to double check my tube chart, but either way, this resistor was out of spec. It was about double the resistance. And I have some new parts coming in, so we'll get to those when they come in. I'm just doing some prep ahead of time for that. And I'm trying to spend as little time as possible working on this. Try to see how fast I can do this, really. Not for any particular reason, just for my own skills. Should probably be wearing a mask instead of holding my breath. Cool. And like with any vintage amp, all of these are going to go in a baggie with the amp. So actually, I already started collecting them. If I ever sell it, people like me like to have as much of the original stuff as possible. Best if you can use it, but I'm not the kind of collector that just lets stuff sit around. I like to use it. Cool. And then probably the same thing. I'm gonna try to pull the negative end out, but not likely. Always have to be mindful of space in here. Yeah, I didn't think so. Okay. But I did flow that blob a little bit so that I can actually get a little bit closer to the end. Just carefully. Great. Now the one thing I didn't show, because I lost the footage, but actually have to double check where these are coming from. I think these are feeding the output speaker. Okay, so this must go from the AT7. This feeds 6 V6s. Okay. So yeah, this must be right before the final power tube section. Anyway, these leads, wasn't quite able to fit these fat capacitors underneath it. I might be able to do it for this one though. Yeah, so this one I think I'll be able to, but for this one, definitely not. This is gonna be way too tight. Yeah, I don't want to apply excessive pressure, so I'll just run it underneath. And just be mindful of the capacitors in the way here. This wire, they gave me enough room here. And then I should just be able to have this stand a little bit high. And that's still underneath the plane. Last thing I want to do, I have to sort of check that, is that I don't want this to be proud of the lip here. So when you pull the chassis out, I don't want to rip that capacitor off the eyelet board, so just being mindful of the space that I have. But I think I'll be all right there. So I think we can be done. So we've decapped the old capacitors. I have a new diode coming. I don't trust that diode. I think I might have just cooked it. It was probably at the end of its life, and better to replace that since that's on the bias circuit. I don't want to introduce any noise from that rectification, or try to limit that as much as possible. So let's look at our schematic and see what those resistors are supposed to be. I have a feeling they're probably going to be out of spec. I ordered a set. So we can replace everything. All right, I saw my markups here. Okay, so this is our cathode bypass circuit. So we're expecting, sort of get my right orientation here. So that was our first cathode bypass for the 12AX7s. And then this would be for the reverb. And then this would be for our tremolo. No, let me see what I'm looking at here. So this is our signal comes out, goes into our AT7, our output transformer, our reverb driving transformer. Okay, and then we float into our reverb input from the output. So that's must be a gain stage for the reverb. Okay, because the AT7 is a lower output than the 12AX7. So okay, I think I'm understanding here. So let's go look at our reverb circuit. So we have 2200 is what we're expecting on that cathode bypass for the AT7. So 2200 and 2200. Okay. Oh, because this is a split cap, that actually feeds the other 12AX7 as well, doesn't it? So that goes here. That's our, okay. Since there's two triodes in the 12AX7, I believe. So yeah, don't need my iron right now. Let's go to resistance and do some poking in here. Alright, so this first one should be 22. 23, okay, that's fine. And then the other side of that 12AX7 should be an 820. Yeah, 820. Okay, let's take a look. Yep, yeah, that guy's too high. Okay, so it's worth replacing those. And then let's move down to the next cathode bypass cap. So here we're expecting 2700. So let me see where we're at on our circuit here. So this is so we just checked this, guys, and now we're on our third one over here, and this is our 12AX7, 2700, 820. This is on our reverb output. Okay. So there's our 820 on the other half of the 12AX7 on the output of the reverb. And then so that's the 820 side, and then the 2700 side is the AT7, I think. No, the AT7's over here, and it's another 12AX7 for the tremolo. So our first half of the triode. That's our cathode bypass for the trim. Okay. So let's see. So this would be our 2700. Ooh, that's just barely. Got a pack of 10, so I'll just replace that one. It should be 820. Oh, that one's fine. Okay. Yeah, interesting. So that's a good 820. You can see because that's 850 and 10% of 800's 80, so well within that. Versus this is also supposed to be 820, but we're at 1K. So, and that would affect our flow from the cathode to ground. Okay, cool. And then, you know what, let me just sanity check this last. Yeah, this is 115K. And I believe it's supposed to be a 27, or am I wrong? No, it's supposed to be a 56. But you know what, let me just make sure I'm not in the wrong spot here. So this is our cathode bypass on this 12.8X7 for the tremolo. So yeah, once pin 3 is here, so that's our first. Oh, actually, you know what? That could be okay. So this is on our second triode of the 12AX7. It's supposed to be 100K. Yeah, so that's the circuits, I think, maybe not labeled correctly because they have 56K in the layout, but they have 100K in the circuit. And I'm inclined to believe this circuit diagram. That's what I've been doing previously, so I guess I should stay consistent. So if that's supposed to be 100K on the second triode, what did I measure? 100 something? 116. I mean, that's technically out of spec. So I'll just replace it just for good measure. I have 100Ks coming anyway, so just to be safe. All right. So I think we'll probably just stop here. That's probably enough for today. Won't change out the electrolyte caps until the resistors are changed. Doesn't make sense to do that until we're done with the resistors and be even closer to turning this thing on safely in any way. Probably just double check our grid leak, our resistors, and just make sure those are in spec on our input channels. I haven't checked up here near the pots for both channels. So I haven't checked these resistors, but I should probably make sure those are okay. And then yeah, I think we're good. All right, I'm gonna see where that order's at, but yeah, hopefully we'll be done this week. Turn this thing on and see what it sounds like. See ya.